Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the Electrical Engineering channel. In this lecture, I will discuss some examples, and in these examples, I will be using Gaussian elimination method to solve simultaneous equations of third order. Okay, so it is a 3 by 3 system in which we have three unknown variables x, y, and z, and we have three equations, and the solution of this system has to be evaluated using Gaussian elimination method. So first we will perform forward elimination, and these three system of equations are represented in the matrix form as follows. So this is our A matrix, this is x, and this is B. So AX is equal to B. So let's start eliminating the elements of this system matrix and transform this matrix into an upper triangular matrix. So first of all, we will make this entry equal to 0, and we will perform this operation R2 minus 2R1. So multiply the first row with 2 and subtract from the second row. So this is the overall step, and this first entry has become 0, and second entry is 5, and the third entry is minus 3, and this is the right hand side entry, which is minus 18. So this system is represented in the augmented form, and this is our new second row. Similarly, new third row is also operated to convert this entry equal to 0. So this will be achieved by performing R3 minus 3R1, right? So this is the operation, and after this operation, our new third row will be 0, 1, minus 12, minus 15. Now we have to make this entry equal to 0. So multiply the third row with 5 and subtract second row from it. So this is the detailed operation, and after this operation, we will get minus 57 and minus 57 over here. So now this system has been converted to the upper triangular matrix. Now we will first evaluate the value of z. So the third row can be written as minus 57 z equal to minus 57. So z will be equal to 1. Now we will expand the second equation, which is 5y minus 3z is equal to minus 18. So we have evaluated the value of z equal to 1. So 5y will be equal to minus 15 and y will be equal to minus 3. Now we will expand the first equation, x minus y plus z is equal to 8. And we have evaluated the values of y and z. So x can be evaluated as 4. So 4 minus 3, 1 is the solution. Now let's solve another example of Gaussian elimination method and evaluate the values of x, y, and z. So this system has been represented in the augmented form. And first of all, let's evaluate the new second row, in which the first entry is equal to 0. So R2 minus 2R1 will be performed, and this is our new second row. Similarly, now convert this entry to 0, and R3 minus R1, and it will be 1 3 minus 3 1 and 1 4 minus 1 4. So let's subtract the second this row from this row. So we will have minus 1 minus 2 minus 3, and this is our new third row. So now let's convert this entry equal to 0. So this will be achieved by multiplying the third row with 3 and subtract the second row from it. So it will become minus 3 minus 6 minus 9 and minus 3 10 7. So after subtracting, this will be plus, and these two symbols will be minus, and at the end we will have minus 16 minus 16. So this is our new third row. Here we have two zeros as well. Okay, so now let's evaluate the value of z first. Minus 16 z is equal to minus 16, so z is equal to 1. Now expand the second row, minus 3y plus 10 z equal to 7. So we will have y equal to 1. Now expand the first row, x plus 4y minus z equal to 4. And solve this equation, put the values of y and z. So we will have x equal to 1 as well. So 1 1 1 is the solution. Now let's solve some examples of LU factorization, and we are given this example. This is the system matrix, and we have to evaluate the U matrix, which is upper triangular matrix, and we have to evaluate the L matrix, which is lower triangular matrix. So first of all, we will perform these two operations. R2 minus 2 R1. This will convert this entry equal to 0. Similarly, then we will perform R3 minus 3 R1, and this operation will convert this entry equal to 0, and these entries will also change. So this is our new matrix in which we have 1 minus 1 1 as the first row, 0 5 minus 3 as the second row, and 0 1 minus 12 as the third row. And this entry has to be made equal to 0 now, right? So this entry has to be made equal to 0, then it will be the U matrix. So this is very important point in LU factorization, that whenever we are eliminating any entry of the system matrix, we have to multiply the upper row with some number and subtract the upper row from the lower row. So that will always be the case which has to be followed every time, right? So for example, if we want to convert this entry equal to 0, then we want multiply the third row with 5 and subtract the second row from third. We will always multiply the upper row. So upper row is the second row. So let's multiply the second row with some number such that this pivot entry becomes equal to this entry. So we have to multiply the second row with 1 by 5 and subtract the second row from the third row. So R3 minus 1 by 5 R2 has to be evaluated. And this is our R3, 0, 1 minus 12. And 1 by 5 R2 will be equal to 1 minus 3 by 5. Right? So subtract the new second row from the third row. So we will have 0 over here, 0 over here. And this will be equal to minus 12 plus 3 by 5. So let's simplify this. So it will be equal to minus 57 by 5. So minus 57 by 5 will be available over here. So this is our U matrix. Now the L matrix is equal to diagonal entries equal to 1, and we have three zeros over here, the above diagonal entries, and the entries below the diagonal are equal to A21 over A11, A31 over A11, and A32 dash over A22 dash. So A21 over A11 can be evaluated from here. This is A21, this is A11. Similarly, A31 over A11 is equal to 3. So A21 over A11 is equal to 2, A31 over A11 is equal to 3, and A32 dash over A22 dash, this is our this entry. And these entries can be evaluated using these formulations. This is A32 dash, this is A22 dash, and their ratio is equal to 1 by 5, which is equal to 0.2. So this is our lower triangular matrix. This is 2, this is 3, and this is 0.2. And one shortcut method is that these two entries A32 dash and A22 dash may not have to be calculated separately. Instead, if we observe this matrix, after converting these two entries to 0, we have to observe these two entries. This is our A22 dash and this is our A32 dash. So if you not evaluate these two entries explicitly, you can observe that you already have these entries calculated. So A32 dash over A22 dash is equal to 1 by 5 is equal to 0.2. So you can put 0.2 directly over here and that will give you the answer. So this is our lower triangular matrix. Now let's solve another example, and in this example we are given the system matrix as this, and let's convert this entry equal to 0, and this will be achieved by R2 minus R1. So after this operation, these are our new entries. So this entry is already equal to 0. Now the only thing is to convert this entry to 0. So this will be achieved by multiplying the second row with 8 by 14, right? Multiply the second row with 8 by 14 so that this entry becomes equal to 8, right? So it will be minus 8, and then we will add the third row in this new second row. So uh, that will make this entry equal to 0. So 084 is our third row. Multiply the second row with 8 by 14. So it will be minus 8 and minus 8 by 14 multiplied by 9. So let's add these two rows. So this will be equal to 0 and it will be 4 minus 8 by 9 divided by 14. So let's simplify this. So it will be 4 minus 72 by 14. So it will be minus 8 by 7. So this is equal to minus 8 by 7 and this is our upper triangular matrix. And we have to remember that this is our A22 dash and this is our A32 dash. Now let's evaluate the lower triangular matrix and it is written in a straightforward way over here. So this is A21 over A11 and A21 over A11 is equal to 1. So this entry is equal to 1. This entry A31 over A11 will be equal to 0 and this will be equal to A32 dash divided by A22 dash. This is our A32 dash, this is our A22 dash. So in the lower triangular matrix, the entry over here will be equal to minus 8 by 14. So this is minus 8 by 14, so minus 4 by 7. So these are diagonal entries which are equal to 1. Here we have zeros. This is 1, this is 0, and this is minus 8 by 14, or it is equal to minus 4 by 7. So this is our lower triangular matrix. Now we can double check our solution if this is correct or not. So multiply these two matrices, L matrix and the U matrix that we have evaluated. This is our L matrix and we can multiply it with the U matrix. This is our U matrix and we can evaluate the result of this multiplication and it is equal to this matrix. And this matrix is equal to A matrix. So the product of L and U matrices must be equal to our original system matrix, which is our A matrix. So if this product is equal to the system matrix, then it means our solution is correct. Otherwise, we have made some mistakes. So you can check this multiplication by yourself, and at the end, you will see that you get the same system matrix. So I think you have understood how to evaluate the L and U matrices and how to perform Gaussian elimination method. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.